All right, so today we are going to perform operations with complex numbers. So the first thing you need to know about is our imaginary unit, and it's I. And I is equal to the square root of -1. Can we take the square root of negative numbers?
No.
Not really. And so that's why we've invented I, this imaginary number, so that we can take the square root of negative numbers. This allows us to solve problems that previously we couldn't solve. And so if I were to square I squared is going to equal, what do you think? Well, the square root undoes, when you square something, it undoes the square root, right? So I squared is equal to -1. Okay? So the square root of -1 times the square root of -1, it's going to equal -1. So for example, if I have the square root of -3, that's like the square root of -1 times the square root of 3, right? So instead of the square root of -1, I just write I, root 3. Okay? And then going the other direction, suppose I take that I root 3 and I square it. That means I've got I squared times 3, which is -1 times 3, and so that equals -3. So any questions so far? Basically, I is always the square root of -1, and I squared is always -1. Okay? All right, so let's use it in some problems and see what happens. So I am going to solve the equation 2x squared plus 11 equals -37. So the first thing I would do is subtract 8 from both sides. I mean, subtract 11 from both sides. Where did the 8 come from? I don't know. And so I get 2x squared is equal to -48. And when I divide by 2, I get x squared is equal to -24. So normally, before we knew about imaginary numbers, we would have just said no solution at this point, because you can't take the square root of a negative. Well, the more precise answer would have been that there is no real solution. There is, however, an imaginary solution. And so I take the square root of both sides. And so that's like I'm taking the square root of -1 times 24. So x squared, or x is going to just equal I times root 24. And it's actually plus or minus, right? Because we can have a positive and a negative. Okay, but my root 24, I can break that down further, can't I?
Yeah.
Yeah, the square root of 24 is 4 times 6, isn't it? So I can take the square root of 4 and take that out. So I get x is equal to plus or minus 2I times the square root of 6. So I'm going to have you guys do this one on your whiteboards. A little less complicated here. Remember, when you take square roots, you've got a positive and negative answer. All right, it looks like we're all agreeing it would be that x equals plus or minus I root 13. All right, here's one a little more complicated. Let's have you guys do this one on your whiteboards. All right, so you guys were getting that x squared was equal to -28, right? Because we added the 8 to both sides. And so when you take the square root, Negative 28, that's negative 1 times 4 times 7, right? And so x equals plus or minus 2I root 7. Looks like most of you got there eventually. Okay, any questions there? All right, so now we'll move on then. All right, so complex numbers. What a complex number, it has a real part and an imaginary part. And so the standard form for a complex number is we put the real part first and the imaginary part second. So a plus b times I. That's my real part. And that's my imaginary part. And if a is equal to 0, then I have a pure imaginary number. Okay. So when we have complex numbers, we can add and subtract them, just like we add and subtract real numbers, or add and subtract expressions with variables. You basically combine the real parts, and combine the imaginary parts. So if I look at this first one, I've got 8 minus I plus 5 plus 4I. So the real part is the 8 and the 5. And then the imaginary part is the negative I and the plus 4I. So it's just like combining like terms. What's 8 plus 5? 13. What's negative 1 plus 4? 3. So I have 3I. So the answer would just be 13 plus 3I. You're just essentially combining like terms. Yes? You don't have to write the I like an italic, but that is how it is in the book and everything. Yeah, I just do it that way so that I can see it better. That if you just write a straight I with a dot on the top, that's fine. I'm not going to mark you off for it or anything like that. Okay? All right. So I want you guys to try this one on your whiteboard. All right, so it looks like we were all getting 3 plus 6I. All right, let me show you another one. Now we're going to subtract instead of just add. So now I've got 7 minus 6I, and I'm subtracting 3 minus 6I. So you want to be careful. Essentially, you want to imagine that you have a negative 1 that you're distributing out, okay? And so if I distribute the negative into that second parentheses, I'm going to have a negative 3 and a positive 6I. So that's the main thing you have to be careful of, is just don't forget to distribute the negative. So now if I look at my real parts, I've got a 7 minus 3. And then my imaginary parts, I've got a negative 6I and a positive 6I. So in this case, my imaginary terms cancel each other out, and my final answer is just 4. So is 4 a complex number? Actually, it still is. It's a complex number where b is equal to 0. So it's also a real number. But a real number is a subset of complex numbers. So, yes, Lonnie? Okay, all right. Okay. All right, so let's have you guys do this one on your whiteboards. All right, looks like everybody was getting the same thing, negative 5 plus 9i. All right, one more thing we're going to do today is multiply them. All right, so we've added, we subtracted, we're going to multiply. We'll worry about division tomorrow, okay? But we are going to multiply today. All right, so we're going to write the answer in standard form, and we're just going to use the distributive property like you would any other time. So if I do 4i times negative 6, I get negative 24i. And then 4i times I get 4i squared. Okay, now do you remember at the beginning what I squared equals? Everybody, what does I squared equal? Negative 1. So that means that this is the same as negative 24i plus 4 times negative 1, which is negative 24i minus 4. Right? Do I have it in standard form? Is the real part first? No, so we just need to switch it around. So negative 4 minus 24i would be my answer in standard form. Okay? So I'm going to have one for you guys to try on your whiteboard. All right, so if I distribute, we get 9i, right? And then we get minus I squared. So that is 9i minus negative 1, isn't it? So minus and negative is the same as plus a positive. So it's actually a positive 1 plus 9i. So be real careful with your negatives. All right. One more I want to show you, and one more you guys will do on your whiteboards. All right, so for this one now, it's just like when we multiply binomials. We're going to distribute the first term to both and the last term to both. So 9 times negative 4, I get negative 36. 9 times 7i, I get 63i. Negative 2i times negative 4, I get a positive 8i. And then negative 2 times 7i, negative 2i times positive 7i, I get negative 14i squared. But what does I squared equal? Negative 1. So really I have negative 14 times negative 1. What's that equal? Positive 14. So I'm going to have negative 36. I'm going to go ahead and move my positive 14 right up next to it so that my real parts are together. And then the 63i and the 8i. And then I just combine my like terms. So negative 36 plus 14, I get negative 22. And then 63 plus 8, I get 71i. Any questions on that? All right, so you guys still have 2 minutes left, so don't you dare pack up before you do this problem. We've got 3 plus I times 5 minus I. That's your ticket out the door today. You have to be able to do this problem. All right, so you guys got 15 minus 3i plus 5i minus I squared. That's minus a negative 1. So 15 plus 1, we get 16, and then plus 2i. All right, so what does I equal, everybody? I is equal to the square root of negative 1. So one more time, what does I equal? The square root of negative 1. What does I squared equal? Negative 1. All right, have a great day.